All right, good morning everybody and welcome to Portland. Thanks to the organizers this year for having this in Portland. We really appreciate you guys coming. This is great. David and I are going to talk about Embedis today, which is an embedded dictionary server, and something we have been working on for a little while now. And so I'm Tom Moxon, this is Dave Turnbull. Let's see if I can get this to advance. Having a little problem with this, Zach. Can you get it?
Try the space bar.
There we go. Okay, so what is Embedis? Embedis is an open source library for Arduino that implements a key value store. And the reason we wanted to do this, I've been working in embedded systems since the early 70s, and so I've pretty much worked on almost every platform out there. Starting very early from the PDPs and onto microprocessors as they came. And over 30 years of doing this, you know, one of the things you notice is you see a lot of patterns that get repeated as technology advances. And so one of the things that we wanted to do was to make this a little bit simpler for you all to use. And there's been a plethora of new permanent storage out there, things like non-volatile SRAM, ferromagnetic RAM. We've had double EEPROM for a long time. And so one of the things that we noticed is that they're a little bit difficult to use because they have different access methods and there are often different libraries written to access them. So one of the things we wanted to do is kind of make that a little bit easier for people to use and kind of homogenize the interface and the APIs for doing that. And that was really kind of how Embedis came about. Embedis also came about because I wanted to work with David. He's an excellent engineer, and we kind of came up with this project as a way to work together on something. And I'm really very pleased with how it came out, and especially his work on the core key value store and the implementation of the command line interpreter. It's really nice work. But Embedis was designed to be small, simple, and extensible. So the idea is that you can actually add to this just by wiring in your own methods and your own memories for your own system, or use the built-in methods that we have. And if you're familiar with Redis protocol, it was designed to be very similar to Redis so that we could use a lot of the same bindings that Redis uses, Perl, Python, Ruby bindings, for actually accessing the databases that you create within your embedded systems. And it also includes familiar pub/sub commands, and we have ways to interface this to MQTT and other IoT standards. The other thing that we wanted to do is to include hardware read-write commands so that you can actually access hardware subsystems from this as well. And that also is extensible. You can add to that as well. It's all open source on GitHub under ThingSock Embedis. And so supporting a number of different permanent storage all at the same time has been problematic up to this point. And so what we can do with Embedis is treat the same interface for NVS RAM, for flash, for SD cards, and with a simple command line interface and a consistent API for that. And there are a lot of good drivers out there for things like MRAMs and NVS RAMs and things from Adafruit and SparkFun, and so we wanted to be able to allow you to lash those up very quickly and reuse a lot of the other open source code that people have written for some of these permanent storage devices and do a very quick lash up using Embedis for that. So in Embedis, basically every thing is a dictionary for terminology, and David wrote a really excellent internal built-in function, but you can also declare your own custom dictionaries. So if you want to have your own, or if you have an existing store, and I'll talk about that in a little bit, you can implement those as well. But for example, on the first one here, this is how you would declare a dictionary for the internal EEPROM. So in an Arduino and the AVRs, you typically have anywhere from 1 KB, 2 KB. And one of the things that we did was enabled you to store the keys for that in Flash to use less space. And David wrote an interesting way to use very, very small memories by using the long ASCII key name and putting that in Flash and just putting a pointer to that in the EEPROM itself to save space. And so you can do that or not. And it also works on platforms that don't have any internal EEPROM. For example, in the ESP8266 platform, the EEPROM is emulated in the Flash, and there are drivers for that. And so when you look at this, we're defining the name of the dictionary, the size of the dictionary, and then the methods for read and write. And if there happens to be a commit, something that you have to do before the write actually takes place, there's a space to put that method in as well in the definition of the dictionary. And so because in the ESP8266 platform, the EEPROM is actually emulated in Flash, you actually need to call a commit function to commit and actually do the writing for that. And for example, on the Due platform, which is Cortex M3, there is no internal EEPROM, just like the ESP8266. And so again, we use an emulation, the Flash Dewey, to emulate the EEPROM for that. And similarly, you can use external I2C or SPI EEPROMs or FRAMs just by defining the access methods for those. And once you define the dictionary and the access methods for those, then that all just functions correctly in your system. So what's really good about Embedis is it allows you to separate your program and data. And this is something that I see a lot, especially when I teach classes at schools. And for young novice programmers, they really don't understand the concept of separation that much. And so what you see a lot is you see in Arduino Sketch where people have hard-coded in, what pin for what LED, for example. And then when you change that from, say an AVR to an ESP or some other board, you've got to change that setting. Same kind of thing with your SSID and other settings. And so what we do in Embedis is we allow you to put that into the data store and then access that from your program so that you can put that a different, for example, LED pin number on each board that you've got, and then your program just accesses that out of the database and automatically configures itself. And so that's the same kind of method that you can use for putting in your SSID and your password for getting on Wi-Fi and other authentication methods. So for example, here what we're doing is doing the API call to get the LED, and if it's not found, it defaults to 13, but otherwise in that case, you pick out what LED, and so each of your boards can have the LED pin setting written in its Embedis store, and so your program doesn't change. And so the idea is you have tested code and configured code, and if you're doing anything in production, if you do a Kickstarter campaign or whatever for your product and you want to put a serial number in, you don't want to embed that in the code because then you've got to recompile the code for each board. So the idea is you put this in the Embedis data store, and then all you have to do is configure the EEPROM for each with its custom data. Same kind of thing with the station ID for Wi-Fi SSID or password. If it's not there, it defaults to nothing. And so here's an example using the flip and click board from Micro, which has 4 little memories on it. So it includes a flash memory, a FRAM, and a double EEPROM. And so those come up as different dictionaries. For example, the SPI FRAM and the I2C EEPROM, as well as the internal. And so using the dictionaries command, you would get those. And so for instance, if I wanted to select the flash, you can see down here that we get, it tells us if we select the flash, how much we've allocated. 1K bytes of flash comes back, and that's how much we have for our key store. We've written a lot of examples for this, and they're under the Hackster site at ThinkSock. And so you can go and download these, and there's a lot of teaching examples there as well. And we also did an MQTT example there where you can write an arbitrary string as the key in Embedis called the MQTT under Embedis. And then whatever you store in that will actually come up and be published on your MQTT. And that's an example of how we use the subscribe and publish functions. And the last thing I'll talk about is the device tree. We actually organized it so it works with the device tree as well. So Embedis writes from high memory to low memory, and the device tree goes from low memory to high memory. So one of the things we're working on is putting a device tree integration where you can actually do a get and set on the device tree atoms, basically from Embedis. And how can you help? You can give us some comments on how you're using Embedis and what features would make it more useful. We're also looking for some programming help on some of the examples that I talked about. So if you want, speak to me afterwards or send me some email. And thank you. You know, this work would not be possible without all of you and all the work that you've done.
If we lost our video, I can talk a little bit about, well, we lost our video, so I can mention a few things about.
That's right.
We're fine. So as a developer, I have specific needs. Tom mainly focused on our hardware. And I just wanted to mention a few of the things that I put in there that are helpful to us developers. Now, one of the things when you're working with an embedded system is it's sometimes difficult to debug. Instrumenting code on a constrained platform is a challenge. Sometimes you want to wait for certain events to handle. As Arduino developers, you know we don't have a debugger. So one of the neat things is the ability to quickly instrument your code. The Embedis is primarily a command line tool. So you can provide this command line on a serial port, on a network interface. We have Telnet, we have HTTP, and we have the serial port as examples. But anything that implements the stream object in Arduino can be made to run Embedis. Now, if I was interested in the status of a temperature sensor that was flaky, let's say it ran for 10 minutes and then stopped, what I could do is use the pub/sub mechanism and just continuously publish the temperature, but it won't show up on any of the interfaces until I go to an interface and I subscribe to the channel that I publish to. And that means that I'm not looking through 5 minutes of useless data. I can wait for whatever event triggers the bad data and then go look at it. Or add commands to forcibly switch the device into a bad mode. And all this stuff is as ad hoc as I could make it on an embedded platform. We talked about the dictionary a lot, and the dictionary does not need to be defined in firmware, right? You can have known things like SSID and password for your Wi-Fi network, but a customer who buys your product might have special needs, like a asset control or inventory control or asset management systems where they wanted to store information on all their devices and be able to retrieve them and manage inventory and so forth. And they don't need to work with you at all. They can just put their data on the EEPROM as long as there's room, and there's usually always room these days. And they'll be all set to go without changing your gold master ROM. And that's all I have to say.
All right, I think our time is up. So thank you very much.